Welcome engineers, my name is TravisIQ, and today we're discussing CCNA questions, specifically VLAN, mostly VLAN security questions. Let's take a look. Join me in the void as we begin this discussion. So the first question, a network administrator needs to secure all unused switch ports that are currently assigned to the default VLAN. Which two actions should the administrator take to enhance port security? So we're gonna go down one by one and decide, is this going to enhance port security? And then also which two would be best, because it's always a kind of a best situation. A here, disable the ports administratively. Disabling the ports administratively, that means I can't use them at all. That doesn't seem very functional. But what they're saying here in the question, if we read back to the question, your initial thoughts are, I don't know if we should do that. If you read back though, these are unused ports. So if you think about unused ports, that's probably a pretty valid solution. So this is probably a pretty valid answer. I'm not gonna say that it's a required answer until we get through all the questions, but this is definitely on my list. Configure the ports as trunk interfaces. I would actually say this is probably the antithesis. This is probably the opposite of what you want to do, right? Because if you configure those ports as trunk port interfaces, what does that mean? That means that it's going to allow you to transmit traffic from all VLANs or also to receive traffic from all VLANs. And so that's probably not going to increase the security. As a matter of fact, it will not. So B really isn't an answer that we're even going to consider here. Aggregate the ports into an ether channel group. Ether channel bundles, realistically, this doesn't really contribute to security at all. The only thing I would say is ether channel bundles are notoriously difficult to set up and actually might just fail on you and act like a secure config, but that's not the case either. So this isn't really going to contribute to security. D, set the ports as access interfaces and assign them to VLAN 999. So 999. So set the ports as access interfaces. The first part of this, again, they're trying to kind of mess with you here, right? Disable administratively. You're like, I don't know. Access interfaces, that's giving them access to the network, and then assign them to 999. And so what they're asking you to do is think like a network administrator. And now if you're thinking as a network administrator, VLAN 999 might indicate something to you, and a seasoned network admin would know here that VLAN 999 is often configured as the black hole VLAN, or a VLAN that you never configure other interfaces in, useful interfaces or attached interfaces to other devices, and that means that it goes nowhere. And so this is a typical black hole VLAN. Black hole. Woo! And that means then that this is trying to be a secure configuration. And now you might say, well, Travis, I don't know if it's actually a black hole VLAN or not, given the information in the question. I agree. But what I'm going to say is this is a consideration for one of those two configurations that's going to contribute to security. So we have to go down to the last one here. And the last one is enable LLDP, the link layer discovery protocol in the interfaces. And again, LLDP is actually going to contribute to the devices determining what other devices that they are connected to. Right? And so that's what LLDP does, is it allows devices to basically autonomously, to some extent, determine what other devices they are connected to, specifically network devices. And so the link layer discovery protocol being enabled is actually going to make this less secure as well. And so we have three options here that we would actually say objectively are not secure configurations, and two options that we would say are potentially secure configurations. A being a very secure configuration, and D being, a network administrator known secure configuration. And so I would say that the answers here should be A and D. And so this makes a lot of sense given our knowledge of the protocols as I described them, and our knowledge of secure configurations, and a little bit of background knowledge for network administrators and seasoned network admins. And now you have a little bit of that background knowledge as well. Question 2 here. After two switches are configured as shown, and I would actually argue that there's not the full configurations here, but enough information to make some inferences. Pings fail from PC A to PC B based on the output shown. Okay, so we have the output here. We have a diagram. It says which issues need to be addressed. And based upon this configuration, what you can garner is that it should work. So what they're trying to say is, if you look switch 1, the switch port is enabled, and you can see they really only identify one interface here. So then you might say, Travis, I see switch port enabled, administrative mode trunk, encapsulation. You're like, encapsulation is a per interface config. Trunking is typically a per interface config. Switch port mode enable is on a per interface. I'm not giving any interface information here. You are, if you look at the diagram, you really only have one interface labeled. It's pretty clear that you can infer that these configs are for those interfaces that are labeled, and also their trunk ports, right? So what do trunk ports do? They are typically, right, these switch-to-switch connections, or sometimes they're switch to router for router on a stick or things like this, but they are network device to network device where there's multiple VLANs that are going to be traversing that link. That's what a trunk port does, or a trunk link allows. And so the trunk here is here, trunk, trunk, encapsulation. 802.1q is a trunk encapsulation type to identify VLANs and additional information. So this is making sense to us. I'm giving you this information so that we can make the inferences that we need to answer the question. Negotiation is off, so DTP is off. Access mode VLAN 1, so we're saying that we are allowing VLAN 1 for sure, right? Trunk VLANs enabled. There's actually some additional VLANs enabled as well. We have some native VLAN assignments. This is all indicating to us this is a trunk port. Okay, great. So which issues need to be addressed? DTP is configured on the G01 interface of switch 1. So we look at switch 1. DTP is the dynamic trunking protocol. This negotiates trunks between switches in a Cisco environment. And so this is trunk port negotiation. DTP is off. Also, we have trunk administratively set up, so we don't need to do negotiation. We set this up as a trunk. DTP is not going to cause us any issues here. It is off, and the trunk ports are assigned already, so we're good. There is a mismatch of allowed VLANs on the trunk. Is there a mismatch of allowed VLANs? Trunking VLANs enabled, 50 to 100, 50 to 100. There actually isn't a mismatch of allowed VLANs. And even if there were, that may not cause us problems, but they specifically did not make that change so that this wouldn't even cause you a problem. So we actually know here that A and B are not issues. Here we have C, the ICMP configuration is mismatched between the PCs. The ICMP configuration is mismatched between the PCs. I actually kind of alluded to this earlier. We have no idea what the ICMP configuration is. And now they're asking you to understand protocols though. So they're asking you to understand protocols and the well-known nomenclature as network engineers. Ping is the common verbiage for ICMP, right? So this is ICMP. So they're actually asking, you see ping and then you see ICMP and you're like, ooh, they're saying ping is failing. It's an ICMP mismatch. You're like, I know that ping is actually ICMP. Now you're getting some information and you know some things. And you're saying this might be the answer here. But again, the configuration information hasn't been given here. And what is, if you've been a seasoned network engineer, what's the likelihood of an ICMP configuration mismatch where like if ICMP is configured and allowed and both PCs support ping and there's a weird configuration setting that doesn't allow PCB to process the ping request? It's unlikely. It's possible, and I'm sure some of you have run into that in the real world, but it's very unlikely. So I would say that this is, I'm not going to put like multiple X's here, but I would say this is pretty unlikely given that we don't have enough information to make that assertion. I would say if there was no other answer here that worked at all for this question, then maybe you would say, okay, maybe it's an ICMP config issue. That's the only thing that even makes any sense. But at this point, I would say that that's very unlikely. Let's go on to the next one. D, there is a native VLAN mismatch. Now we go here and we say native VLAN 99 and native VLAN none. And now you're going to ask yourself, Travis, 99 and none, I mean, basically none is unassigned, and then you're like, well, if it's unassigned, does that mean it's mismatched? This is where they're trying to confuse you. You're saying it's not 999, it's something else. It's 999 and none, right? Basically, it's 999 and a null value, and you're like, and then someone behind the camera here is going, Travis, a null value. If a native VLAN isn't set, it has a value, and I completely agree with you. I'm telling you what I see in the configs, and if I don't understand what the configs mean, that's what I'm going to interpret it as. What it actually means is, if the native VLAN is not set, there is a default native VLAN, and we talked about this actually in one of the previous trunking videos. I'll link that in the description below. But the native VLAN, the default behavior of the native VLAN is actually to set the native VLAN to 1. So now there is a native VLAN mismatch. One side says 999 and one side says 1. If you've tried to set a trunk up like this, you know that you will get an error in the Cisco CLI for the setup that says native VLAN mismatch and the trunks won't set up. The reason for this is this would actually allow VLAN hopping, and we can go into some security at a later date. I think I might have mentioned this in a previous video as well, but it's going to allow VLAN hopping, and you don't want that to happen. It's going to take untagged frames and put them in the wrong VLAN from one side to another. So you won't even be allowed to set up a trunk link with a native VLAN mismatch. This is going to cause ping issues very likely. So I'm going to check this, and then I'm going to go down one more to make sure that I have this answer correct. I will tell you on an exam, if I had limited time and I kind of knew that I wanted to rip through some of the really well-known questions, I would probably actually stop here and answer this question, rate it D. I would click D and move on. But I'm going to go through this here for you so you can think through my thought process. And if I had enough time, I would actually, if I felt like I was moving through them quickly enough, I would actually continue on and make sure that I could validate that D really was the best answer here. If we move down, the PCs are in the incorrect VLAN. First of all, we actually have VLAN assignments on these ports. I know it kind of says it on the link, but that's basically a port assignment on the switch. So they are both in the same VLAN, even though we are in VLAN 99. And you're like, Travis, weren't we talking about that's kind of a black hole VLAN that really shouldn't be assigned, or oftentimes is colloquially used as a black hole? I agree. They've done this to confuse you. 999 is being used in this environment, and PCA and PCB are both in that VLAN. So I would actually argue, right, that this is very likely not going to cause you a problem because the PCs are in the correct VLAN, and honestly, 999 is within the range of VLANs allowed too. So all of this sets up well, except for one very important fact. There is a native VLAN mismatch, and this will cause a problem with the trunk link setup and will not allow you to forward that VLAN traffic. So D is the answer here. Answer D. And then we can come back and say the ICMP configuration is mismatched between the PCs. We don't have enough information to make that assertion, so D is obviously a better answer here. And this is how you run through these questions with diagrams and configurations and all this stuff meant to confuse you. You make an assertion about the question first. You say, hey, what am I looking at here? Okay. You look at the question. You say, hey, this question aligns with what I was looking at. And then you go line by line, honestly. And finally, the third question here. So we have another exhibit, a very similar exhibit here. It says, refer to the exhibit. The network administrator wants to make sure that switch 1 and switch 2 will not require any change to the frame checksum when forwarding traffic on VLAN 40. All other VLAN traffic does not need to meet this requirement. Whew, okay, so they're saying that when VLAN 40 gets forwarded, we want no change to the frame checksum? This is really interesting. What's going to change the frame checksum? And so there are some examples of things that changed the frame checksum or failing the frame checksum, right, with PCA forwarding malformed packets or whatnot, or runts or giants. So we could have runts or giants or things like this where it's failing frame checksums and not allowing traffic to be forwarded. But I don't really know until I look at the questions because I need some information from the answers in this question to determine what this frame checksum even means. And so I'm gonna actually start at the bottom. So which command accomplishes this task? What am I trying to do between switch 1 and switch 2? So if I say switchport access VLAN 40, so if I put G0 and G1, right, let's say we need VLAN 40 to be forwarded. So now this is really interesting. I said all other VLAN traffic does not need to meet this requirement. So if I say switchport access VLAN 40, that means that actually all the traffic between G01 on switch 1 and G01 on switch 2 all are going to have to be VLAN 40. So I would actually argue that this doesn't meet that requirement. That means that no other traffic is going to be forwarded. And not that the other traffic doesn't need to meet the requirement, right? When it says doesn't need to meet the requirement, what it's saying is other traffic can be forwarded. That's an inference, but it's pretty accurate here. If you were to have a boss say this to you and say, hey, the other VLAN traffic doesn't need to meet that requirement for whatever reason, the boss isn't saying no more VLAN traffic should be forwarded here. What he's saying is the rest of the VLAN traffic is good to go. And so I would actually argue that the switchport access VLAN 40 is no good here. This is not going to meet the requirements that are described and referred to in the exhibit. Switchport trunk allowed VLAN 40. Okay, so now we're getting into some interesting stuff here. Switchport trunk allowed VLAN 40 will allow traffic on VLAN 40, and you don't know if other traffic will be allowed or not. So I'm not saying this meets the requirement or doesn't. It is kind of odd because you can't really determine whether frame checksum is going to be changed here or not given this information. And I'm going to leave this open, and you'll see why in a second. So I can't tell you one way or the other. I can say this is going to allow VLAN 40 traffic, and they haven't told me which other VLANs need to be allowed or what other VLAN traffic is on this link. So I'm not saying that it's explicitly wrong, but it's not explicitly right either because I can't make a determination. And if you remember from the previous question, making a determination is a pretty important thing given that the question has an answer. This isn't Jeopardy. I don't give you the answer and ask for the question, right? All right, just a little inside questioning joke there. B, switchport mode DTP. So then I allow these interfaces to auto-negotiate trunk links. Again, auto-negotiation of trunk links doesn't necessarily prohibit frame checksums from being changed on this link for VLAN 40. It allows for the negotiation of the trunk link, which very likely, if it's going to negotiate the trunk link and not set up VLANs allowed and just allow VLANs if the trunk were to be set up appropriately, which we don't even know if it would because we don't know what the interface settings are here. Even if that were to happen, if VLAN 40 were allowed, it's going to be tagged with VLAN 40 with a VID. And when you tag a VLAN ID on a frame, what do? You add a tag, something like an 802.1q tag or an interswitch link tag. When you add a tag like this, what happens when you add a tag to a frame? Frame, and then another tag. What happens when you add this? It changes the configuration of that frame, and that means that you have to change the frame checksum at the end. Now this is starting to make sense. And you could intuit this. Maybe you knew this about adding VLAN tags already. But what it's actually doing is it's saying, hey, we can't add these tags here, because if I add this tag, then it's going to change the frame checksum. When you don't add a tag is when the VLAN is assigned as the native VLAN. So if we assigned VLAN 40 as the native VLAN, that actually would not add a tag and would not result in a frame checksum change. So if we go back to the question, will not require any change to the frame checksum when forwarding traffic on VLAN 40. If we look at A, switchport trunk native VLAN 40. And then you'll say, Travis, I don't know if the native VLAN on switch 1 is also set to 40. But again, you have to make that inference here, because this is the only command on switch 2 that will definitively do what the question is requiring you to do. And so A is actually definitively the best answer here. And I told you, if we go back, switchport mode DTP, now you can see why I say switchport mode DTP, switchport trunk allowed VLAN 40. These aren't definitively telling us that 40 is the native. It's actually saying that the VID is going to be 40 on either of these links, even if trunking were set up in the switchport mode DTP. So I would actually argue that B and C would result in a VLAN ID and a tag being added, depending upon what the tagging protocol is, like 802.1q or interswitch link ISL. So B, C, and D will all result in that tag being added. The only thing that would not result in the tag being added is A. And that takes us through 3 questions. Bet you didn't think it was going to take us that long to get through 3 questions. As is always the case, engineer, break stuff, have fun. We'll see you next time. Let's go.